All right, so this week you have a lot of assignments due, so I'm gonna start with 9.1, which is the polar coordinates. I'm not gonna finish it. I'm gonna finish it on Thursday. So normally, what is a polar coordinate? So when we have XY plane, and I have this point, let's say 1 comma 2, that's your X and Y. So this is, we call it in a Cartesian plane or XY plane. Now, we want to convert something into polar coordinates. That one is a little bit different. Uh, because in polar coordinates, it uses r and theta, where r is the length of the radius, and this is the angle. So if you use, if I go on the polar coordinates, which is, we call it polar axis, and if I use any other point, let's say right over here, this is angle theta. Let's call this point P, r theta. Then this length is called r, and this is theta. So if I'm looking at the point 2 comma pi over 4, so the way I would look at it is angle pi over 4 is right over here, and I call this length is to be 1, 2. So that's my point 2 comma pi over 4. That's all. Now the issue becomes is, what if I give you something on polar coordinates converted into xy plane, or xy plane to polar coordinates? That's what we'll be looking at. But let me give you another example of it. -3 2 pi over 3. Well, for polar coordinates, always find the angle first. Angle is this way, right over here. This is that angle. This is the angle, sorry. 2 pi over 3 is right over here. 2 pi over 3. And now how do you find 3 right over here? Here's 1, 2, 3. This is arbitrary length. Because it's -3, it's going to go to the opposite direction. And that's your -3 2 pi over 3. Your final answer will have this. If you look at it carefully, this angle is not 2 pi over 3. Because you have this negative, you started with the angle 2 pi over 3 and went to the opposite. So if I give you a point, let's say 3 comma 5 pi over 3, 3 comma 5 pi over 3, 5 pi over 3 would be somewhere over here, roughly right over here. And 3 would be 1, 2, 3. That's your 3 pi, 3 comma 5 pi over 3. Now, do you remember your coterminal angles? Let's say if this is pi over 3, if I go back up again, it'll be 7 pi over 3. Things like that. Or if I go negative side of it, it will be -5 pi over 3. So these are all coterminal angles. And we're going to come back and we're going to, let's do this one problem. So if I give you 3 comma pi over 6, let's draw 3 comma pi over 6. Let's call this 3 comma pi over 6. I want to get the same angle, same polar coordinates, but with different numbers. Instead of 3 or pi over 6, I want different numbers. So let me give you the first criteria, where r is greater than 0, but the angle theta is from 4, it's greater than or equal to 2 pi. So it's going to go around it again. So r is greater than 0, but it has to go around it, where I can make that r to be 3, which is +3. So if one angle is pi over 6 and goes around it, the coterminal angle would be 13 pi over 6. What if I make r is less than 0, but angle theta is 2 pi? It's from 0 to 2 pi. So this is the tricky part. Note that the angle is negative. So whatever the radius is negative. So whatever the angle is, it has to be negative. Therefore, it has to land this direction. Since it has to land on this direction, the initial angle has to be somewhere over here. So the point is going to be -3, but what is this angle? Now this angle, the whole thing is pi, and all the way over here would be pi over 6. The whole angle is 7 pi over 6. So your final answer is 7 pi over 6. So you go up to 7 pi over 6, but then because of this negative, it goes to the opposite side, and that's how you get all the answers. Okay, so I'll come back and I'll finish it. You have a lot of stuff due, so that's why I've extended it.